This is the Snap-on MT1665 Counselor. It's a digital oscilloscope that will allow you to take an efficient and streamlined approach to automotive testing and diagnosis. The Counselor is designed with you in mind. It's compact, portable, easy to use, and packs a lot of diagnostic power. Everyone has different levels of automotive knowledge. This presentation is designed for those of you with some automotive ignition scope knowledge and experience. But remember, whatever level you're at, you'll find the information in this tape very useful. The presentation is arranged in 6 sections. Number 1, hookup and operation of the Counselor. Number 2, proper automotive test procedures. Number 3, cylinder shorting test procedures. Number 4, primary screens. Number 5, secondary screens. And number 6, special patterns. Presenting the Counselor will be Bill Large of the Snap-on Product Promotion Department. Bill is an ASE certified master auto technician with 20 years of automotive experience. In section number 1, Bill will cover proper hookup and operation of the Counselor.
Proper hookup of the Counselor is the first step. On the back of the unit is the AC-DC switch. Select the position depending on how you're going to power up the unit. Also on the back is the 110 power connection, the lead set plug-in, and the DC power connection. The number 1 wire loop and the 3 auxiliary terminals, ground, battery, and distributor, are here to provide you the ability to tie in one of our timing lights or our LumiMag timing meter. This allows you to use that timing light or meter through the Counselor's lead set rather than hanging another set of leads over the fender. The DC power cord must be hooked up for the auxiliary terminals to be live. On the front of the Counselor in the lower right-hand corner is the on-off switch. Also in the lower right-hand corner is a thumb wheel for brightness control. The Counselor is about as user-friendly as we can make it. There are not a lot of knobs, switches, or push buttons that tend to be confusing. As you look at the unit, the keyboard is basically self-explanatory. There is an enter key in the upper left-hand corner for the purpose of entering information. You will also use this key to select the edge of the cursor curtain that you want to move, and it will toggle between trigger and expand. The reset key will take you back to square one, allowing you to start over. The instruction key will access 21 pages of instructions that are designed to help you become familiar with using the unit. The freeze key is a manual freeze feature that will allow you to freeze the waveform or bar graph at any point in time that you want so that you can analyze a still waveform. The green keys will access the screens. You have 2 primary voltage screens, which are primary pattern and dwell bar graph. You have 2 secondary voltage screens, which are secondary pattern and KV bar graph. You have a cylinder shorting bar graph, which includes carburetor balance. The alternator and fuel injection key will call up a menu of 3 areas that you can look at: alternator pattern, fuel injection pattern, and voltage pattern. The numbered keys will be used for selecting cylinders, shorting cylinders, carburetor balance, and entering information. The clear key will be used for clearing information from the KV bar graph and cylinder shorting bar graph. The arrow keys serve several functions. They will be used to advance forward or to back up through the instructions. They will allow you to shift the waveform, expand the waveform, and call up the cursor curtain. The RPM set point is an automatic freeze feature. It gives you the ability to program in an RPM and have the screen automatically freeze when it reaches that RPM. Everything that you're going to view will be seen on the screen. You do not have to look at the screen for certain information and then somewhere else for other information. As you power up the Counselor, the first thing you're going to see is the Snap-on screen. The information on the screen is going to be relative to the last vehicle you worked on. The Counselor is going to prompt you through using it. It's going to ask questions that need to be answered. Is this information correct? Press 1 for yes or 2 for no. In this case, you would look at the information and press 2 for no. since this is not the correct information for the vehicle you are now testing. At this time, two things happen. One, you will wipe the memory because you don't want information from a different car that doesn't apply, confusing you on the car you are now testing. And two, it will allow you to program new information for the vehicle now being worked on. Again, it's going to ask questions that need to be answered. Please enter the number of cylinders. At this time, you would go ahead and program in the number of cylinders. If that data is correct, press enter. The next question the counselor is going to ask, is it a 2 or 4 cycle engine? And you would identify the cycle and press enter. The next thing the counselor is going to tell you to do is to enter the firing order. The nice thing about putting in the firing order here is that on every screen you call up, the firing order will be there. It will help you identify the exact cylinder you're looking at. No longer do you have to look at it and wonder, is it the 4th one in the firing order, or is it actually number 4 cylinder? Once the firing order is in, you would press enter. Then you're going to come back to the Snap-on screen and you're going to review this information. You would look at it and say, yes, this is the proper information, and then press 1 for yes and carry on. On the next screen, you're going to see if there was anything saved in memory, it would be indicated by an asterisk in front of the screen that's saved in memory. You have nothing in memory now because you've programmed the counselor for a different car. If help is needed at this time, press instruction. You are now going to go into those 21 pages of instructions that we talked about, and it's going to tell you that the arrow keys will advance forward or back up through the instructions, that we provide you with 8 diagnostic screens, and that they're accessed by the green keys. You're going to see 2 pages of table of contents, which will tell you what information can be found on what page. And then you're going into lead connections. We're going to tell you exactly where the lead hookups go. Next, we're going to take each screen one at a time. We're going to tell you how to get into it, a little bit about what you're going to see, and all of the features available in that screen. We will start with primary pattern, go to secondary pattern, alternator pattern, fuel injection pattern, voltage pattern, dwell bar graph, cylinder shorting bar graph, and KV bar graph. Again, how to get into that screen, a little bit about what you're going to see, and all of the features available in that screen. From this point, we're going to take those features and explain how to use them. Cylinder shorting and carburetor balance, how to do these tests. The cursor millisecond feature, which is basically the ability to measure a part of that waveform. The expand feature, the ability to expand it out and take a better look at it. The freeze feature, again, the ability to freeze that screen at any point in time you want to take a better look at a still waveform. The memory feature, and how to recall it from memory. The RPM set point, which is our automatic freeze feature. Our standard and special trigger, which gives you the ability to shift the waveform. And the reset key, which takes you back to square one and allows you to start over. The instructions are there as a basic guide to help you until you become familiar with using the counselor. They're functional. They will tell you what to do and how to do it. Another nice thing about the instructions is that if a new man comes into the shop, it will help him learn how to use the counselor. The unit has a basic 5-lead hookup. Black and white leads will go across the battery, black to the negative terminal or a good vehicle ground, the white to the positive terminal or to the alternator output terminal, or to a voltage test point depending on what test you're doing. The yellow lead will go to the negative side of the coil or the tach terminal. The inductive pickup is going to go over number 1 plug wire. The secondary pickup will go over the coil wire on a remote coil, or in the case of General Motors HEI integral coil system, you would use the HEI adapter and place it on top of the distributor. The adapters that come with the counselor will help to access the TAC terminal on certain vehicles. We have 2 adapters for Ford TAC terminal, and we have 2 adapters for GM's HEI TAC terminal. Several fuel injection adapters are included for port type injectors and for throttle body injectors. In fuel injection work, you would move the yellow lead to the fuel injector adapter. We recommend that all leads be hooked up to the vehicle during testing unless otherwise stated. This helps to prevent tester instability, which can give you inaccurate information. At this point, you can go anywhere with the counselor that you care to go. We don't give you a program to work with that says you have to start at point A and go through each step. Many times all you want to do is take a quick look at secondary ignition, or possibly go to cylinder shorting for the purpose of determining a bad cylinder. You can access any screen at any point in time that you want simply by pressing a key. Again, we don't force you to work with a programmed sequence. However, we do provide a tune-up analysis sheet that gives you a tune-up analysis test sequence to go through if you care to use it. Also provided with the counselor is an excellent user's manual. This user's manual goes into everything that we've talked about up to this point, and in addition, takes each screen a section at a time and provides valuable information that will be helpful on interpretation of what you're seeing on the screens. It is definitely a valuable aid to this piece of equipment.
In section number 2, Bill will discuss proper automotive test procedures.
No piece of equipment, no matter how elaborate or how costly, is going to solve your problem simply by you hooking it up to a car. All equipment is designed to give you good, usable diagnostic information that will aid in solving a given problem. It is up to you to interpret this information. Your ability to interpret this information will be directly related to your automotive education and experience. Let's talk about the common sense approach. First of all, listen to your customer. There's a lot of diagnostic information that can be gained from him. Ask him questions. Get all the information you can about the specific problem he has. Try to find out under what conditions the problem's happening. What specific condition is required in order to duplicate the particular problem he has? Does it do it only when it's hot? Only when it's cold? Does it do it all the time? Talk to him. He wants to tell you about his problem, but you've got to be able to pull that information out of him in a manner that's usable for you. Once you have talked to your customer and obtained all the information you feel you need, verify the complaint. Is the problem there just as the customer said it was? Find out. Take that car for a drive. Try to recreate his conditions. Don't overlook the 5 most important resources you've got for diagnosing a problem: your sense of sight, hearing, taste, smell, and touch. Visually inspect the vehicle for any obvious problems. Listen for any noises that may be telling you when and where the problem is happening. Use your sense of smell. Is there an adverse odor that could be telling you something? Is it gasoline? Is it a burnt wire? See and feel that belt or hose. Is it soft? Is it fraying or cracked? What condition is it in? Now let's get involved in our testing. Use every resource at your disposal. Get those shop manuals out. Get those schematics out. Get any piece of information out that may be relative to this particular problem. Don't try to rely on just your personal experience to get the job done. There's a tremendous amount of resources available to you in printed form that will very well help you with a particular problem. Let's approach our testing in a systematic way, a step-by-step procedure. Let's not overlook the basics. Don't assume that if you have a code stored in the computer that it is a computer-related problem. Don't assume that if you have a fuel problem that is either carburetor or injector related. It may be somewhere else within the fuel system. Don't assume that because you've got an electrical problem that the battery is bad or the alternator is bad. There are many other components within the system that could cause a problem. As you carry on with your testing, you're going to go through stages. You're going to move from area or general testing to system level testing, and then on to component level testing or pinpoint testing. When you start out, you're going to have to identify the general area that the problem is coming from. Is it a particular cylinder? As you identify the area, you are going to move down to system level testing. Is it an electrical, mechanical, or fuel-related problem? And as you begin to identify the particular system that it is in, you are going to start to pinpoint what component within that system could be giving you the grief. Is it a plug, a wire, the cap, or the rotor? Is it lean or rich fuel? Or is it caused by a mechanical problem such as valves, rings, or pistons? As you move along through the testing process, you'll begin to narrow in on the particular problem. In most cases, you will identify it. In some cases, you may not. You may get into the system level of identifying whether it is electrical, mechanical, or fuel, but at this point you may need to back up your testing with some other testing, such as a compression test, a fuel pressure test, a vacuum test, or a test of some other type with another piece of equipment. The counselor may not always identify your problem, but it will give you information that will tell you what is not the problem. You will be able to eliminate particular areas of concern and say, well, I know it isn't this, and I know it isn't that. However, I know this is the specific system, so I will have to deal with that system with other means of diagnostics in order to pinpoint the problem. The counselor is a tremendous tool, and it will give you a great deal of information, but it is not the cure-all for everything.
Section number 3 examines cylinder shorting test procedures. Once again, Bill Large.
In order to do an accurate cylinder shorting test, certain steps must be taken to ensure the accuracy of the test. You must divorce the computer from the system. You have to take away its compensating abilities that affect engine speed. The way to do this will vary car to car and system to system. Refer to manufacturer's recommendations in cases that you're not sure of. In general, for all cars, make sure that the air conditioning compressor does not cycle when you're doing the test. If it's equipped with an electric cooling fan, make sure that it doesn't cycle when you're doing the test. Disable the EGR system and air management system. An example on a late model General Motors automobile might be 1. Put the engine in initial timing mode per underhood decal. 2. Disconnect the oxygen sensor. 3. Disconnect and plug the vacuum hose going to the fuel pressure regulator. 4. Ground the diagnostic terminal in the assembly line diagnostic link connector located underneath the dash. 5. Disconnect the idle air control valve and then proceed with your test. You can see that doing this is not a simple procedure anymore. Pay attention to the specific recommendations for the car you're working on so that you can get an honest test. And don't forget to clear any trouble codes after testing is completed. As the cylinder shorting bar graph is called up by pressing that key, the screen will be identified. You will have an RPM value and a timer in seconds. The firing order will be laid out, and you will have a numeric display as well as a graphic display. Features in this screen are freeze and memory. We feel the counselor provides you one of the most accurate ways to do a cylinder shorting test. When you start to short cylinders by selecting that cylinder's numbered key, You would press and hold the key to short the cylinder. At that time, the RPM will freeze so you know exactly what RPM you started at. And the timer will start so that you know for how many seconds the cylinder was shorted. At the end of the test, let go of the key and look for the numeric and graphic results. Once you've identified the RPM that you started at and the number of seconds that the cylinder was shorted for, you're going to want to hold those values through the rest of the test. As an example, if you started at 1,000 RPM for 3 seconds, then each successive cylinder should be shorted as close as possible to 1,000 RPM for 3 seconds. In this manner, you're going to get as accurate a test as you can. When you're done with all the cylinders, you're going to be able to stand back and look at the results to see if there are any differences that stand out. Do you have a problem, or does everything look okay up to this point? Now you make a determination. By selecting either the even or the odd key, you will move into carburetor balance. On carburetor balance, you're going to short every other cylinder in the firing order in the manner that the carburetor feeds the engine, and be able to determine how well the carburetor is adjusted. This is a valid test on V-type engines with split plane manifolds, with multi-barrel carburetors or dual injector throttle body units. As you short every other cylinder in the firing order by selecting the even or odd key, the RPMs will freeze so you'll know exactly what RPM the test started at, and the timer will start indicating how many seconds you've shorted that group for. At the end of the test, you're going to have the numeric and graphic results of the test. After the test, stand back, look at the results, and make any determination as to what group of cylinders tested good or bad. We recommend that when doing cylinder shorting, that you short each cylinder for 2 to 5 seconds, and wait 5 to 10 seconds between cylinder shorts to clear raw fuel from the catalytic converter. Likewise, when you get to carburetor balance, remember you're shorting several cylinders at a time. You want to be careful not to overheat the catalytic converter by dumping too much fuel. So allow extra time between cylinder shorting groups.
In section number 4, Bill will take us through the counselor's primary screens.
The primary screens are primary pattern and dwell bar graph. On the primary screens, you're looking at low primary ignition system voltage. You will be picking up the signal from the yellow lead, which will be hooked up to the tach terminal or the negative side of the coil. As you look at the screen is going to be identified. In the primary pattern screen, there will be displayed an RPM value and an average dwell value. The firing order will be laid out with the highlighted cylinder being the one you're looking at. And you will have the primary waveform. Features in this screen include cylinder shorting, cursor millisecond, RPM set point, standard and special trigger, expand, freeze, and memory. We will explain these features in detail when we get into the secondary pattern screen. As you look at the waveform, from 1 to 4 is the dwell section. During the dwell period, you might see a current limiting hump on those systems with electronic current limiting, such as GM's HEI, some Fords, and others. Many use automatic dwell control, which can be tested by observing if a desired dwell change occurs with changes in engine speed. This is a valid check of that circuit of the module. From 4 to 7 is the firing section. From 7 to 8 is the intermediate section, which includes the coil oscillations. And from 8 back to 1 will be a short period with no current flow before the process starts over. Even though you are looking at a low voltage primary screen, there is a direct relationship to what's happening in the secondary. You want to train yourself not to look for secondary problems in the primary and not to look for primary problems in the secondary. Deal with each screen with respect to the problems that you may or may not be looking for. In the dwell bar graph, the screen is identified. You'll have an RPM and average dwell value. There will be a graphic display of dwell per cylinder. The graph is laid out in degrees and percent so that no matter what the specs are given in, you will be able to read it directly. The firing order is there to identify the cylinders. Features in this screen include freeze and memory. As you use this screen for diagnostics, a comparison to the analog scope will be of some use. You would have used the primary raster pattern on an analog scope to obtain the same information that you can get here with the dwell bar graph. You're going to be looking for dwell variation, and you will be doing a module test to determine if the automatic dwell control function of the module is doing its job. You'll be dealing with three types of dwell circuits on today's automobiles. The most common being dwell that will increase with an increase in RPM. The second most common would be dwell that remains constant. And on a few, you will see dwell that will decrease with an increase in RPM. These are valid checks of the ignition module.
Section number 5 covers the counselor's secondary screens. Here's Bill Large.
The secondary screens are secondary pattern and kV bar graph. Secondary screens will show high secondary ignition voltage as opposed to the low voltage that we had with the primary screens. The signal will be coming from the secondary pickup. The secondary pattern is accessed by pushing the secondary pattern key. As you see, the screen is identified. You'll have an RPM value in the upper left-hand corner. A firing line kV value relative to the cylinder you're looking at is in the upper right-hand corner. You'll have the firing order with the highlighted cylinder being the one you're viewing. And of course, the waveform. In the upper left-hand corner under RPM will be trigger or expand. Trigger basically refers to the ability to shift the waveform. The waveform can be shifted so that the firing section is closer to the left side of the screen. This is called standard trigger. It can also be shifted towards the center of the screen. This is called special trigger. The dual function arrow keys will be used for this purpose. You will toggle between trigger and expand by using the enter key. When in the expand mode, the arrow keys will allow you to expand the waveform. The manual freeze feature can be used to freeze the waveform at any desired time. Anytime the waveform is frozen, two things happen. One, it automatically goes into memory. And two, you can call up the cursor curtain simply by pressing the right arrow key. As the curtain is called up, you will have an arrow show up in the upper right-hand corner, which will tell you that you can move the right edge of the curtain. The two arrow keys will now move that edge to the right or to the left. The enter key will toggle that arrow back and forth, allowing you to move the left edge of the curtain. Again, the arrow keys will move it right or left. The RPM set point, our automatic freeze feature, is available here. Simply pressing the RPM set point key will call up the ability to program in an RPM. Once you've programmed in that RPM, press enter and then the screen will automatically freeze at that RPM or at some point above that RPM depending on the rate of engine speed increase. As the secondary waveform is analyzed, there's a tremendous amount of information available to you here once you understand how to read it. Anything that is read vertically on the scope is voltage, and anything horizontal will equal time. Now, as you look at the secondary waveform, you're going to look at it from the primary turn-on right on through every step of the sequence until it starts over again. At point number 1 on the waveform, primary current is going to turn on starting the dwell period. Then at point number 4, primary current turns off. When the current turns off, the magnetic field that had built up in the primary and secondary coil windings during the dwell period collapses. The firing line now from point 4 to 5 is going to represent all the voltage necessary to overcome the resistance in the secondary circuit for that cylinder. At that point, we'll start the spark at the plug. The voltage then is going to drop to the spark line, which is number 6, and that is going to be the voltage necessary to sustain the spark at the plug. The spark line length is going to represent the length of time that we can keep the spark going. This is also called burn time or spark duration. At point 7, as the air-fuel mixture starts to burn out, the remaining coil energy cannot sustain the spark and the spark extinguishes. Then, during number 8, the unused coil energy is dissipated as decreasing alternating voltage continues until no energy is left and there is no current flow at number 9. The ignition cycle is then repeated for the next cylinder in the firing order at number 1. Now what you're going to be interested in is more about the firing line, spark line, and coil oscillations. This is where a lot of information is going to be taken from. The height of the firing line should normally be between 4 and 18 kV. This is going to vary engine to engine and system to system. You're going to be looking for a value here that would be relative to the system you're testing. The height of the spark line typically should be 1 to 4 kV. The spark duration is typically 1 to 2 milliseconds. 8/10 or less is too short, and more than 2 milliseconds is too long. When you get into the coil oscillations, you're going to want to see 3 or more oscillations, which indicates a good coil. Anything less than that, you're going to start looking for problems. With analog scopes, you used to do a couple of tests in a parade or raster pattern, which we display differently. However, the same information is still available. For example, on a maximum coil output test, we used to tell you to open circuit a secondary wire by holding it away from ground and measuring the voltage on the screen. Then the voltage that you measured would tell you something about the coil when compared to specs. Now we're saying, do not open circuit the secondary wires. The voltages and amperages that these systems are capable of producing can find a path to ground. They can damage the ignition system, the computer system, or possibly injure you. What we're telling you to do now as a maximum coil output test is to measure the spark duration. If you have approximately 1.5 milliseconds of spark duration, it indicates good coil output. Also on the secondary circuit resistance test, you're basically looking at the height and length of the spark line. By measuring the spark duration and the height of the spark line, you will be able to obtain the same information relative to secondary circuit resistance that was available before on the raster pattern of an analog scope. Moving into kV bar graph, accessing the screen is a matter of pressing the kV bar graph key. The screen is identified. You'll have an RPM value, the firing order is going to be laid out, and you're going to have a graphic representation of the voltage requirements per cylinder. It is, in essence, the secondary parade pattern. We're also going to give you minimum and maximum numbers here. The minimum number is going to capture and maintain the lowest kV value that that cylinder has seen. The maximum number is going to capture and maintain the highest kV value that that cylinder has seen. These numbers will only change when the minimum sees a lower value or the maximum sees a higher value. As you view the numbers, you're going to want to analyze them in terms of what they're telling you at an idle or no load, and by monitoring how they react under 2 different types of tests, the snap acceleration and the underload test. In both situations, you stress the ignition system in a little different way, looking for something that's breaking down. By understanding what you're seeing versus what you should see, and watching the change in these numbers as these tests are performed, you are going to be able to pick out obvious as well as marginal problems. During KV testing, you would want all minimum numbers to be about the same. You would also want your maximum numbers to be about the same. They should also be within the proper range of 4 to 18 kV. As the values are compared cylinder to cylinder on the bar graph side, you do not want to see more than a 50% variation of the kV bars. Now, I'm not talking about comparing the minimum numbers to the maximum numbers, simply the lowest bar to the highest bar. The other thing that would be done is the snap acceleration test. This snap acceleration should be a quick stab of the throttle from idle towards wide open throttle. Again, when doing a snap acceleration test on an analog scope, you would watch the parade pattern and you wouldn't want to see the firing lines jump over a particular value. Now, by analyzing the change in the minimum and maximum numbers from before snap to after snap, we're able to give you not only the same information, but more information with respect to what's happening to the spark plugs in the cylinder or to the ignition system outside the cylinders. As a general rule, if the min and or max numbers changed adversely as a result of that throttle stab, the problem is inside the cylinder. If little or no change was noted in the min and or max readings, then the problem is outside the cylinder. Problems affecting the air-fuel mixture, such as vacuum leaks, carburetor problems, or fuel injection system problems, can cause abnormal kV readings. Lean air-fuel mixtures cause high kV requirements, and rich air-fuel mixtures cause low kV requirements. The underload or brake torque test is intended for automatic transmissions only. You would use the RPM set point, program in about 1500 RPM to have the screen automatically freeze for analyzing after the test. Press the clear key to start with fresh information. Block the drive wheels. With the brakes applied, place the gear selector in drive. Quickly accelerate to slightly above set point to freeze the screen and return to idle. The information can now be analyzed. The max readings should be similar to one another and within specifications. Again, comparing analog to digital scopes, there were certain tests that you did in the parade pattern of an analog scope that are now done with the kV bar graph. One of them is called coil polarity. On the analog scope, you would look for the parade pattern to be upside down. With our digital scope, look for low mins and low maxes with low bars, and this would be common to all cylinders. This would be telling you that you possibly have reverse coil polarity or a bad coil.
The final section covers the counselor's special pattern screens.
Our special patterns are going to include the alternator pattern, fuel injection pattern, and voltage pattern. We will deal with these one at a time. Pressing the alternator and fuel injection key will display a menu of 3 screens you can use. By selecting that key, you will see on the screen, press 1 for alternator, press 2 for fuel injection, and press 3 for voltage. In this case, you're going to deal with the alternator pattern, so press 1. The alternator pattern will be identified. You're going to have an RPM value and a voltage reading 0.02 of a volt. Features in this screen will include freeze, expand, memory, cursor millisecond, and RPM set point. So the signal for this screen can be picked up one of 2 ways: with a white lead at the battery, or with a white lead at the alternator output terminal. Moving it to the alternator output terminal just gives you a more enhanced pattern. It's a little larger and a little sharper. By operating the alternator under loaded condition, such as turning on vehicle accessories or using a carbon pile across the battery, the pattern is enhanced even more. What you've got with the alternator pattern is a quick look at the charging system. The voltage is displayed in digital form for quick analyzing of regulated voltage. Any waveform other than a known good pattern would indicate that you've got problems. However, some voltage regulator peaks and spikes might appear at light loads. We do include in the user's manual for you many pictures of bad patterns so that you have a reference to compare against. This screen gives a quick look at the charging system for the purpose of determining any alternator diode and/or stator problems. By selecting the alternator and fuel injection key, you're going to go back to the menu. At this point, by pressing number 2, you will call up the fuel injection screen. The screen is going to be identified, and you're going to have an RPM value with a waveform. The features in this screen will be expand, freeze, memory, cursor millisecond, and RPM set point. Adapters for throttle body and port type injectors are included. With these adapters, you will be able to get in series with the injector, and you will move the yellow lead from the tach terminal to the test point on the adapter. Once this is done, you will see on the screen 4 signals of that one injector. There are several things that will allow you to determine the electrical integrity of the fuel injection system. 1, is there a signal? 2, is the pulse width of that signal where you would expect it to be? And 3, does the pulse width change to meet the needs of the engine? At this point, the fact that there are waveforms on the screen tells you that the injector is getting a signal. By using the right arrow key, you can expand one of the waveforms out so that one good injector signal is displayed. With that one good signal, you can use the freeze key to freeze the waveform. Once it's frozen, using the right arrow key will bring out the cursor curtain, allowing measurement of the pulse width or on time of that injector to find out if it is where you expect it to be. Then go back to a live waveform by simply pressing the freeze key. You can do a little throttle work, raising the RPM of the engine to see if the pulse width changes to meet the needs of the engine. If the signal is okay and fuel delivery is insufficient, then you would know that the injector is either inoperative, restricted, or plugged. On electronic port fuel injection systems, a bad injector will affect only that cylinder, so there is no need to test all the injectors if a problem has been narrowed down to a specific cylinder. On throttle body injection systems, a bad injector will affect several cylinders. Refer to the cylinder shorting section of this video for more information about testing these systems. By selecting the alternator fuel injection key, going back to the menu, press number 3. At this point, you bring up the voltage pattern. The screen is identified. You'll have an RPM value and a digital voltmeter reading to hundredths of a volt. This screen is basically a voltmeter. You can do anything that you would do with any voltmeter. You don't have to have all the leads of the counselor hooked up. Simply power up the unit, take the black and the white leads, and go ahead and do any voltage test that you want to do. You can do available voltage tests, voltage drop tests, and being that it is high impedance, you can do some computer work. You can sweep test a throttle position sensor, and you can check voltage at a map sensor or a barrel sensor. By analyzing the voltage waveform, you can check mass airflow sensors and some map and barrel sensors. A list of voltage tests could go on and on. By using the information in this presentation, the examples in the user's manual, and your experience, you will become more proficient when troubleshooting with the Snap-on MT1665 digital oscilloscope.
This concludes the Counselor's Video Instruction Manual. For more information about the Snap-on MT1665 digital oscilloscope, or to obtain a copy of this presentation, contact your authorized Snap-on dealer. This has been a presentation of Snap-on Tools Corporation, Kenosha, Wisconsin.